Hi, my name is John Krontmalny, and I've developed these visual tutorials to accompany any technical training format that might be delivered. In this presentation, we'll explore the different types of electrical prints and diagrams. There will be 3 learning outcomes associated with this presentation. Number 1, identify 2 types of electrical diagrams. Number 2, explain advantages of electrical diagrams. And 3, create ladder diagrams. Electrical diagrams are created to convey ideas about how electrical devices are fabricated and how they work. These diagrams come in 2 basic forms, ladder and wiring diagrams. The ladder diagram is most often used by service personnel once electrical assemblies are delivered. Ladder diagrams have an appearance of a ladder structure. Like reading a book in English, ladder diagrams are starting from the top, read from left to right. Ladder diagrams are frequently used for troubleshooting purposes by electrical service personnel. Wiring diagrams are the other commonly used form of electrical diagrams. Wiring diagrams are used by installers and fabricators to wire electrical components and assemblies together. The difference between these 2 diagramming systems deals with the purpose for which they are going to be used. Ladder diagrams provide for the understanding of the logic behind the circuit. Ladder diagrams are used by personnel for troubleshooting, servicing, and maintenance of electrical assemblies. Wiring diagrams provide information on the fabrication and installation of the devices making up the electrical system. Wiring diagrams can also be used for calibration of individual components making up that system. Most often, ladder diagrams will be used by service personnel. It is important that all service personnel become knowledgeable on its creation and utilization. There are 6 rules involving the creation of ladder diagrams. Number 1, the power of the system is always located at the top. Number 2, read from top left to right. Number 3, input devices are shown to the left. Number 4, output devices are shown to the right. Number 5, inputs are either in series or parallel configuration. And number 6, only 1 output per rung. Referring to the ladder diagram shown, we can apply these 6 steps, beginning with the source of the power located at the diagram top. In this case, we have a step-down transformer with an input of 120 volts AC and an output of 24 volts AC. Next, we start to read the ladder diagram starting at the top left, scanning toward the right on that particular rung. After scanning the first rung, the next rung down is scanned. Ladder diagrams utilize electrical symbols to communicate circuit elements. In this graphic, many of the electrical symbols are shown and could be used in ladder diagrams. As we may remember, switches and contacts are considered input devices and only allow electrical current to pass when closed. Input devices are not loads which convert electrical energy into other forms. The input devices are located to the left of each rung of the ladder diagram. Output devices are considered electrical loads. Output devices are located to the right of each rung of the ladder diagram. In reference to arranging input devices on ladder diagrams, these can be placed in series, parallel, or combinations of these 2 to achieve load control. Output devices are placed in ladder diagrams on the right side of each rung. 1 output device must be installed for each rung. Under no circumstance can there be output devices in series with each other. From these 6 simple rules, we can understand and create ladder diagrams that technicians can use to repair any electrical problem which may occur. Designers of electrical systems create their designs to meet certain customer needs. These needs and expectations are found in a system's sequence of operation. In the sequence of operation, details on exactly how the system will operate will be found. Sequence of operation will determine its design as well as provide information for service technicians to service and troubleshoot appliances. Here is an example of a sequence of operation we can use to create our ladder diagram. An electric motor, a green lamp, and emergency stops will be controlled by 2 operators. Either operator A or operator B shall start an electric motor and a green lamp shall illuminate. Either operator A or operator B shall be able to stop the motor and turn off the green lamp. We can start to create our ladder diagram with identifying the components needed for the system sequence of operation. In this example, our power source will be 120 volts AC coming from any duplex receptacle. Next, we can identify switches, normally opened, maintained switches, and normally closed, maintained emergency stop switches. Finally, we can identify the loads as circles, one with the letter M for electric motors, and the other the letter G for the green lamp. We can start our ladder diagram creation by drawing the source of the power at the top, complete with power descriptions. In this case, 120 volts AC appearing across L1 and neutral. Next, we can place into the drawing the 2 loads, the electric motor and the green lamp. Remember, these loads are placed 1 load per rung and located toward the right. Now we can place into the drawing the input switches that control the 2 loads. In this case, we can place the normally closed emergency switches upstream from the normally open maintained switches. The normally closed emergency stop switches are placed in series to each other, and the normally open maintained operator switches are placed in parallel. Next, we identify each rung in the ladder diagram. Here we can see rung number 1 ending with the motor load. Rung number 2 ends with the green lamp load. Ladder diagrams will have terminal blocks that conductors will be wired to. There will be generally 2 terminal blocks used across each electrical device. Jumper wires can be used to connect certain terminal blocks together. Technicians can use these terminal blocks for measurements using multimeters. Here is the finished ladder diagram created for our sample sequence of operation. Notice that the 6 rules for ladder diagram creation are followed. At the top, we find the source of the power for the circuit. We then read down from this point from left to right on each rung of the diagram. In our ladder diagram, we've placed the input switches to the left of the loads. The loads of the ladder diagram are placed to the right of the diagram, and observing that each load is on its own rung. In order to control the 2 loads in parallel, the inputs are arranged in both series and parallel formats. The emergency normally closed switches are placed in series and are located upstream to the normally opened maintained switches. These normally open maintained switches are placed in parallel to each other so that each operator can have control. Finally, we can see that we are obedient to rule number 6, that there is only one output device located to the right on each rung. Comparing the sequence of operation to the ladder diagram circuit design, we see that operator A or operator B can stop the loads using the normally closed maintained switches. Operator A or operator B can start the loads by closing either normally open switches.